All right, pre-calc 4.4, trig functions of any angles. So we were doing acute angles, trig functions, but now we're gonna, again, you can see like the picture below, that is more than 90 degrees. So if it's under 90 degrees, it's gonna be exactly the same as everything we've been doing. Just good to, again, remind yourself of the ratios of sine, cosine, tangent, cotangent, secant, and cosecant. If we look at an example, so again, our point is at -3, 4. So again, if you think about how it goes, cosine theta, sine theta, so our cosine is kind of in our x categories and our sine is in our y's. So when I look at this, I'm going to say, okay, I don't quite know what r is, but I know that this is going to be my x, which is -3. This is going to go up and be 4. If I use the a squared plus b squared equals c squared, because it's a right triangle, I'm going to get -3 squared plus 4 squared equals c squared, 9 plus 16, which means this is going to be 5. So if I wanted to list out sine, cosine, and tangent, in this example, again, sine is y over my r value, or like my radius. So that would be 4 over 5. Cosine is, again, my x value, which my x was, in this case, -3. So -3 over 5. And then my tangent is y over x, which is 4 over -3. So my tangent gives me -4/3. So we can, even just looking at a single point, again, figure things out about the distance and the angles of that point. And we can also look at just the signage. The signage can really help us determine a lot of this stuff. So if we look at an example here, again, just looking at this in the different quadrants. In sine, in your first example, quadrant 1, everything is positive, okay? In quadrant 2, as we know, our x's, which is like cosine, becomes negative, and our y's, which is like sine, becomes positive, but then a positive divided by a negative still gives me a negative, which is why tangent is negative. But then again, in quadrant 3, negative times negative becomes positive, or negative divided by negative is positive. That's why you get a positive tangent. So really using some of these ideas, you can help to narrow things down. So if I give you an example and I said, okay, it's given that tangent of theta equals -5/4, and cosine of theta is greater than 0. So I want to find secant, or find sine of theta and secant of theta. So we know that theta is going to lie in quadrant 4 because that is the only quadrant in which tangent is negative and the cosine is positive. So again, it was given to me that my tangent is going to be negative and my cosine has to be positive, which has to be bigger than 1. So I see that, okay, I know that my answer is going to be somewhere down there. And again, so if I think about tangent, I know that tangent is like saying y over x, which again, that means that it is negative 5 over 4. So I can almost find sine, but again, in order for me to do that, I have to figure out what my like radius would be, what that other side of the triangle. So again, if I sketched it out, I know I'm in quadrant 4. I'm going to be down here like this. I'm going down 5 over 4. I'm still figuring out what is this. So 4 squared. 4 squared plus 5 squared equals c squared or r squared, whatever. So you're going to be left with the square root of 16 plus 25 equals r. Square root of 41 equals r. So not quite as nice of a number, but I can figure out sine, because sine, if I think about SOHCAHTOA, sine is opposite over hypotenuse. Well, I know that the opposite is negative 5. Opposite over hypotenuse. The opposite is negative 5, and I just found the hypotenuse r to be square root of 41. So when you use your calculator, you get approximately negative 0.7809. The other one we asked was secant, which again, secant is like the inverse of cosine. So that's like taking adjacent over hypotenuse. That's like taking hypotenuse over adjacent, which would be square root of 41 over 4, which is approximately 1.6008. Then there's kind of this idea called a reference angle. Here's some different examples of some reference angles that you may see. Again, if you want to think about the reference angle is what gets it, kind of like it finishes back to 90 or back to 180 or 0. So it's like this extra, we're trying to create it to get back to this straight line. So the reference angle is kind of creating what is left over to get to that 180 or 360 degrees. All right, so just real quick, a few examples. If we want to find the reference angle of theta, so again, if this is theta, our reference angle could be showing like this with a dash. So we want to find these, and so I'm going to say theta equals 300 degrees. B, theta equals 2.3. And C, theta equals negative 135 degrees. So again, in this case, a 300 degree turn, if I just sketched that out real quick, okay, I know that it's going to be all the way something like this, which means for me to finish it, I got to enclose it over here. So I'm going to say, I know that all the way around is 360, which means that my reference angle is 60 degrees for letter A. For B, this is using radians. So again, 2.3 as a number is going to lie somewhere between pi over 2 and pi. So I would say that, if you were sketching it, okay, so again, your sketch is going to be somewhere over here, which means that my reference angle is going to be this area right here. So again, I'm trying to get to pi radians, because this is 0 pi's, this is pi over 2, this is 1 pi. So I'm going to say pi minus 2.3. Again, pi is 3.14. It goes on forever. But we're going to say 3.14159 minus 2.3 is approximately 0.8416. And again, this would be in radians. If we're not using degrees, we're using radians. So you're going to have to specify. And then the last one, what was it? The theta was negative 135. So if I think about theta going 135 the other way, okay, that's going to be like right here. It's going to be located in quadrant 3. So this would be my reference angle, this extra piece. So I would say take my answer, subtract it from 180. I got 225 by thinking about, you could also say, okay, if this is 135, to get here, this would be 180. So 180 minus 135, and you would get 45. Just know, again, you're not going to have necessarily a negative degree for your reference angle. Your reference angle is going to stay positive. I got this 225 from going the other way. I was saying, okay, if I went this way, I would be at 225. All right, couple more examples here. Evaluate each trig function. So let's just say cosine of 4 pi over 3. And then we'll do tangent of negative 210 degrees. So to find this trig function, I would say, okay, I know that 4 pi over 3, if I was just thinking about it, that's going to be in quadrant 3. So again, this gives me 4 pi over 3, which means my little reference angle over here to get back would just be pi over 3. I know that cosine over here is negative 1. This point is negative 1, 0. X is 0. So I would say negative cosine pi over 3. And I know that that answer is negative 1/2. So that's my answer for part A. For part B, tangent, if I think about tangent, okay, negative 210. If I go 90, 180, negative 210, that's going to be up here somewhere. Which means for me to get back to 180, this small little section right here, that would be 30 degrees. So my reference angle is 30 degrees. So I'm going to say that, again, the tangent of negative 210 is the same thing as negative tangent of 30, which is, if I think about my unit circle, okay, at 30 degrees, I've got 1/2 square root 3 over 2. When I do square root 3 over 2 over 1/2, keep change flip. This should be 1/2. I got them mixed up. Okay. Anyways, this is going to equal negative square root 3 over 3. I know why. These ones are the ones that's goofed up. Okay, this is 1/2 and no. X is bigger, so X is square root 3 over 2, Y is 1/2. There we go. So again, this is what I would put for my answer. My answer of tangent of negative 210 is the same thing as negative tangent of 30, which tangent of 30 is square root 3 over 3. So tangent of negative 30 is negative square root 3.